are from National Kaohsiung University of Science and Technology First Campus, and our class says Department of Mechatronics Engineering 2B. Our subject for Sequential Control Theory and Lab is Development of Goods High Detect and Transmission for Storage Management System with PLC Control. Our advisor is Monlonia Distinguished Professor Dr. P.A. and our teaching assistant is Ho Chen En. We are Group 5. We have our members C108、1126于听树、C108、104、206蒋嘉诚、C108、104、220林瑞汉、C108、104、233文世轩、C108、104、239谢振豪、C108、104、266 Cindy Chang Sen
Content. First, summary. Second, next steps. Third, material and cost. Fourth, time management and contribution. 5. Relevance. First, summary. Motivation. Now that the material distribution production line is no longer fully operated by humans, automatic machine transportation will be more convenient and safe. There will be no more operating safety problems. Besides, that an automatic transaction warehouse system can reduce error and become more precise in delivering the products to their place than a human being. Purpose. We decided to use PLC to make an automatic transportation warehouse system, simulating the future process of a locked good to warehouse system automatic factory.
Second, next step. Step 1. Define the problem. Step 2. Make a stage of the process. Step 3. List the sequence of operational steps in as much detail as possible. Step 4. Add sensors as required. Step 5. Add manual control as needed. Step 6. Consider the safety of the machine operator. Step 7. Add emergency and master stop switch as needed for operator safety. Step 8. Create the ladder logic diagram. Step 9. Determine the what-if or potential problem areas. Ninth step. Define the problem. Problem definition. The traditional warehouse system run by a conveyor belt sending the goods to the warehouse. Then it manually distinguishes the height and size of the goods. After that, the system transports the goods to their place accordingly. This method requires a lot of labor cost, while our conveyor belt warehouse system can distinguish the goods height and send it to its fixed place automatically. Next step. Make a sketch of process. This is our 3D view sketch.
Next steps. List the sequence of operation steps in as much detail as possible. This is the flowchart for all systems. The system starts and we come to a decision point. Is there a good in place? If there is no good in the place, nothing will happen. Well, if there is good in place, the conveyor belt button will be pressed and the conveyor belt motor starts to rotate. After that, continue with process 1. We come to another decision. Is the sensor on the conveyor belt being triggered? If no, it continues with process 2. Well, continue with process 3 if it is yes to these questions. For process 2, we can see there are 2 lines of result. The 2 times 2 goods will be sent into the warehouse 1, and the process come to an end, while the 4 times 4 goods will be sent into the elevator. Then elevator platform's motor will start to rotate to send the 4 times 4 goods in the warehouse 2, and eventually come to an end after this. As for process 3, it is in train for the 6 times 6 goods. In this process, the 6x6 goods will also be sent into the elevator. However, 6x6 goods, the elevator's motor will rotate, resulting in the elevator going up. The elevator goes up until the floor sensor is actuated. Then the elevator platform's motor will then rotate to send the 6x6 goods into warehouse suite. And finally come to an end. 9 steps. Adapt sensors as required. Adapt the required sensors above the compute belt. This sensor is used to distinguish the height of the goods. The sensor will only be triggered by the large goods when they pass through the compute belt. When the elevator will bring the large goods to its specific floor. Sensors above and below the elevator will trigger the sensors while going up and down. Actually, the inclined plane in the elevator. As a result, the goods are moved out of the elevator. 9 steps. Adapt sensors as required. Sensors above the compute belt. Sensor above and below the elevator.
9 steps add sensors as required. I introduce the motor's top 2 button. This motor here controls the movement of the elevator, while this motor controls the platform inside the elevator, and this motor here controls the conveyor belt. 9 steps. Add menu controls as needed. 9 steps. Consider the safety of the machine operator. Consider operator safety. The system only requires us to place the goods onto the conveyor belt and use the execution button on the control console. Then the system will automatically distinguish the height of the goods and transport them to the warehouse. 9 steps. Add emergency and master stop switch as needed for operator safety. The emergency switch. When goods accidentally drop off during the transportation process or did not convey smoothly to the elevator, the goods may cause other function failures. At this time, the emergency switch is pressed immediately to stop the machine from operation, reducing more damage. Besides that, the emergency switch should also be pressed when the machine went wrong or an accident occurred during the transportation process.
9 steps. Create the ladder logic diagram. This is our I/O contact table, and for our input, we have X0 is start button, X1 is lower limit switch, X2 is upper limit switch, X3 conveyor belt, X4 lifting button, X5 reverse button, X6 going up button for the elevator, X7 going down button for the elevator, X10 emergency stop button, X11 manual or automatic, X12 6x6 limit switch, and for our output we have Y0 is conveyor belt, Y1 lift, Y2 reverse, Y3 going up, Y4 going down, Y5 indicator light, Y6 conveyor belt light, Y7 is elevator light. 9 steps. Determine the what-ifs of potential problem areas. Consider about if program lose control. Question 1. The motor operates the elevator in a project. What if the motor turns a few more turns as it is being stopped by the program, resulting in the elevator being unable to reach its position? Answer for this question. The error time is accounted for within a few tests. We designed the program to end the motor in advance, and deducting the error time will work. Question 2. Touch sensors require a large amount of force to detect a touch. What happens if it encounters lighter goods? Can it pass through the sensor smoothly? Answer for this question is extending the end of the sensor tilts the force point towards the end segment, allowing the sensor to be triggered more easily. Question 3. Because the conveyor belt is running quite fast, what if the small goods that should have been excluded mistakenly go onto the elevator? Answer for the question is we set up a low embankment in front of the elevator to prevent the small goods from getting onto the elevator. This is the photo for our PLC automatic matching machine.
Third, materials and cost. Materials and cost. Material, FP correct paper, red, cost $48 in NKUST bookstore. Motor, cost $660 in Darwin Electronics. Steel ruler, cost $50 in NKUST bookstore. Wood, cost free in Wood Factory West. Angle bracket, cost $35 in Shopee. Pipe connector, cost $10 in Shopee. LS limit switch, cost $40 in Electric Magnetic Store. Total, cost $808.
Time management and contribution. Time management. We list 4 rows. First row, item. Second row, finish date. Third row, progress. Fourth row, percentage. And item, we list planning, materials listing, purchase 1, purchase 2, mechanics making, electric wiring, design PLC program. First test, correcting the mistakes. Second test, and final test. Contribution. Everyone has their responsible part, and hardware is red color, software is white color, PPT is blue color. Reference. We reference written by Yao Wenlong and Zhou Zhihong. Sequential control using Mitsubishi PLC, Gaoli Book Limited Company, Taipei. Thanks for watching. Does anyone have any question?